As a parent, we love to watch our children play music, read books, volunteer hours at the hospitals, libraries, and participate in soccer games and mock trials and science fairs, etc. You name it. If there is one thing we are not that so excited for our children to play, it's video games. Asian parents are not an exception. Many parents are skeptical, have very negative view on video games, and try to prevent their children from playing video games as much as possible. Yes, children love to play video games, but can you guess the average age of video gamers in the United States? Is it 8 years old, 12 years old, or 15 years old? No. Ironically, 35 to 44 years is the average age range of video gamers in the United States. It is estimated that about 164 million Americans, which is half of our population, play video games. And 75% of all US households have at least one video gamers in their home. In some, 64% of US adults and 70% of those under age 18 regularly play video games. Video game industry is $1 billion business, and its sales continue to increase every year. Playing video games have been criticized or even demonized, often without scientific evidence backing up those claims. Does video gaming ruin our lives and destroy our children's future? Is there anything good about video gaming? According to University of California Irvine studies led by Dr. Craig Stark, some video games is actually good for our brain because it can boost memory functions. Is it really? Let's find out. I'm your host, Dr. Shin. Welcome to my Science Cafe. I'm truly excited to introduce today's distinguished guest, Dr. Craig Stark. Dr. Stark is a neurobiologist. He is a professor and James McGrath Chair of Neurobiology of Learning and Memory. He also serves as the facility director at the UCI campus imaging facility director in the UCI School of Biological Sciences. Welcome, Dr. Stark.
Thank you. Thank you for having me.
Okay, so based on the published research in the Journal of Neuroscience, you quote that students playing 3D video game improve their scores on the memory test, while the 2D gamers did not. The memory boost was substantial, not even small. So the memory performance increased by about 12%. The same amount it naturally and normally decreases between the ages of 45 and 70. Wow. Would you tell us more about this study? Because I'm sure our audience may doubt, is it really truly? But at the same time, we want to learn more about what this study is and what 3D video game you used in the study.
Yeah. So the basic idea for this study didn't come about initially because we were interested in, learning exactly what video games do to the brain. What we were interested in was whether we could take something that researchers have known for a long time really helps in animal studies, and whether we could apply that to humans. And this thing is called environmental enrichment. And the basic idea in all of these studies, whether it's in rodents or even all the way up through non-human primates, if they live in a rich environment where there are toys, there are places to explore, there are things to do and things to interact with, and there's a lot of new stuff going on, it has all sorts of great effects on their brain, particularly on things like memory and on this structure in the brain called the hippocampus that's critically involved in memory. So we wanted to understand whether environmental enrichment worked in people. And a brilliant postdoc of mine at the time, is a postdoctoral research fellow named Dane Clemenson in the lab, had the idea that we might be able to use immersive 3D video games to provide this enrichment. Because if you think about it, game designers these days are putting together these incredibly huge, rich worlds with an amazing amount for you as the player to interact with, and even to choose exactly what you want to do in the path and the style of play that you want to have. And these are entire worlds that you can inhabit. And there's a lot of money behind this to make these very engaging kinds of games. So we wanted to then see, could these games actually be providing environmental enrichment? And if so, would that improve our memory in the same way that decades of research has shown that it works in an animal? So that study you referred to in the Journal of Neuroscience, the very first experiment that we did is we took a whole bunch of people here on the University of California, Irvine campus. We asked them what kinds of games they played, and we gave them a test that my lab has developed that is very sensitive to the functioning of this structure, the hippocampus. And what we found was that those who played games did better than those who didn't game. All right, but there are a lot of things that could go and lead to an effect like this. We're only really going to believe it if we can change it ourselves. So we took about 75 undergraduates who weren't gamers, and we divided them randomly into 3 groups. And one group, you do what you always do, is nothing. Test their memory. We wait a few weeks. We test them again. We wait a little bit longer. We test them again. And then we had these groups that were gaming. In one group, we wanted to have something that was easy to learn how to play, but still had this idea of a rich world that you're in, maybe a 3D game that required some kind of spatial exploration, learning what's going on, where it, and this kind of thing. And we picked the game Super Mario 3D World. It's meant to be able to be played by little kids and older folks alike, and so we had that. And we also then had another game, Angry Birds, in which, well, it's a fun game, it's an engaging game, but you're doing the same thing over and over and over again. If you don't happen to know the game, you're pulling back this little bird in a slingshot to go and try to knock over these structures made of pigs. I don't know where they came up with that idea, but in any case, it's a sort of more of a puzzle kind of game. And what we found was that, well, if we don't do anything to you, or you play Angry Birds for a half hour a day for a couple of weeks, has no impact on your memory. But if you played Super Mario 3D World, it did. It actually improved your memory above baseline and above the other groups there. We saw that the effect lasted for at least 2 weeks. We haven't tested longer kind of durations in that one, but we were able to then see that it boosted memory, in particular, this kind of memory that the hippocampus is involved in. And so this is the kind of thing that let us start to think that, hey, wait a minute, these games may actually be doing that sort of environmental enrichment and improving our memory. Oh, and one last little bit on this. It turns out that also the amount that you did in the game, the amount of that you really engaged with it, all the new places that you went and this kind of thing, some people did more of that than others, the amount that you engaged in the game predicted how much of a memory boost you would even get.
Wow, that's amazing. So you basically use the game as a way to enrich the environmental enrichment tool, just like the lab experimentation, like the rodents or the chimpanzees, and you give them the toys and this 3D games or the 2D games, exactly the same way, but how human interaction and play with those games affects the memory. That's brilliant. And so let me ask you, what is memory? What is memory? Why and how does this 3D Mario World you used improve memory, but Angry Bird didn't?
Yeah. So we know that first off, memory isn't one thing in the brain. You have multiple memory systems that all learn in their own kinds of ways. Now, when we use the term memory, we often think about things like, hey, can I remember where did I put my keys? Can I remember what I did yesterday? Can I tell you these kinds of things? And this sort of fact and event memory, sometimes called explicit or declarative memory. We have a lot of terms as scientists we use for it, but this is the kind of memory that is critically dependent on the hippocampus. And a very, very smart hippocampal researcher, Richard Morris, once said that what this hippocampus does, the automatic encoding of attended experience. So basically, if you give it something new that you think about, the hippocampus goes and tries to stick that away inside of your memory. Doesn't always work, but it tries to do this. So if you're going somewhere new, going to some new part of town or something like this, your hippocampus is firing like crazy as there's a lot of new stuff for it to try to then go and stick into your memory here. And that's then the idea behind these video games, because we can put you in a world that you've never been in. And we have you move around in it, we have you do all sorts of things in it, and these are then experiences that you're having, and it's sort of feeding your hippocampus all of this information. And the mere act of doing it, you can think of it as an analogy to exercise. You're giving it something to do. You're giving it what it was designed to do, what it evolved to do in the first place. And so you're exercising your hippocampus. And it turns out that can then have effects outside of the game as you have a better functioning hippocampus.
Wow. So in that study, you mentioned that young college students play the 3D Mario World 30 minutes per day, every day for 2 weeks. And that's your paper, right?
Mhm.
So does why you choose 30 minutes and does gaming time affect the memory improvement? For example, I mean, if someone play video games 60 minutes long instead of 30 minutes per day, every day, 2 weeks, do you anticipate the memory boost to double at the end of the 2 weeks training?
Yeah, that's a great, great question, and one I am dying to be able to answer. What is the right dosing? Is it 30 minutes a day? Is it 60 minutes a day? The kids will want it to be 8 hours a day. The parents will want it to be closer to the 30 minutes a day, quite possibly. But the truth is, we don't know. We have to run that study. And this is one that I'm hoping to run in the future, in which we also look at things like what happens if you keep playing the same game versus we add in a new game. According to the background, the model that we're working in here, the novelty really is the key part of it. So as you are playing this game more and more and more, and sort of in some ways consuming the novelty in that game, we're going to have to shift it up on you to be able to get something, to be able to keep getting that kind of benefit from it. But, as I like to say, this is an empirical question. It's one that we have to actually go and test to really know the answer.
Yeah. Actually, yeah. So it seems like what's the perfect timing? What's the adequate timing of gaming to bring maximum memory improvement? Or like when we switch games from 3D Mario World to another
Mhm.
3D games because our hippocampus initially excited about, oh, this is the new thing, but it'll become accustomed to the situation and maybe no longer excited
Exactly.
anymore. But we don't
Exactly.
know when is that time point or how long and how much. So to
And the truth is, this is quite probably going to be something that will vary from person to person. And so it's almost an individualized, kind of approach. It may not be that a half hour a day is going to be right for you. That may be right for somebody else. But you can still sort of be thinking about that general principle of giving yourself something new.
So this can be like personalized medicine concept, right? Because everyone is different their genes are different, and lifestyle is different, and environment is different. Just like, so the personalized precision medicine considers all those factors, and gaming may be in one area like very much prescribed game medication to the people who need memory boost or memory improvement. So let me ask you, so to run these studies to find out and answer these very important questions, what you need?
Yeah. So what we need to do these studies, it comes down to what we always need. It's time and money. So to do these kinds of studies, and participants, so we need to be able to get people to enroll and be able to then go through this process of 2 weeks, or we've been doing 4-week long studies. We have planned several month-long studies to then really be able to see, if we assign people to different conditions here, what are these effects? What is the effect of the dosing? What is the effect of the amount of novelty, et cetera, et cetera? And so we always need to be able to get the people to do it. We need to be able to have the funding to do it, to pay the staff, to pay the participants, and that kind of thing. And exactly then to be able to have then that time in the lab for folks to be able to actually keep doing this. One of the nice things, though, about our current situation is that this is the kind of thing that a lot of people can be doing at home. So in fact, we finished up one study here during the pandemic because we were able to have middle-aged individuals. We're looking at the effects of aging on this. And we want to sort of fill in that middle time point. We were able to actually do that with people working at home.
So yeah, definitely to run the study, you need money and time and people and participants. So you usually get research funding from federal agencies like National Institute of Health. But do you accept any philanthropic or corporate funding as well? Because I'm sure there are people who are passionate about this research and interested to see the answers and to help for their parents and for their loved ones. Or the corporate might be the big giant gaming industry interested. Okay, we develop games, but this game actually brings health benefit to the people, to the broader community. Let's put some funding. If that happens, are you allowed to accept those fundings to do the research as well?
Yeah, so that's another great question. Because we've been extending this into exactly as you're getting at that, studies of, is it going to help our parents, our grandparents? And how do we really get that done? So as you mentioned, we do a lot of work with federal grants. And so I turn in large grants to National Institute of Health, particularly like the National Institute on Aging or National Science Foundation, to then try to see, can we run these rigorous studies? In addition, philanthropic kinds of efforts are always very welcome because they can give us the flexibility and the latitude to do things that are very difficult to do in the federal grant review kinds of structure. When it comes to corporate kinds of aspects, it does get more complicated. We want to be able to have people know that the results that we have come up with are unbiased. We all have our own biases, but we try to minimize them. And certainly when there's a corporate sponsor, it does then start to enter in, or at least raises up the kinds of questions in terms of, well, if it didn't work, would you be able to get this would you have actually published the effect? And so you can set things up in such a way to do that. And you always have to be very, very upfront with where your funding has come from so that people can evaluate this themselves. In all of the work that we've done, it's been funded by the National Institute of Health, and it's been funded by the Dana Foundation. So those two sources have been instrumental in us being able to get this done.
Okay, thank you so much. So anyone interested in funding these researches as a philanthropist or the corporate, let us know. But so let me ask you the follow-up questions regarding your study. So your study participants, as you mentioned, are college students and young adults who are tech savvy and they have no concerns on memory loss. Is this memory boost by playing 3D Mario World effective only for those adults? Because you mentioned like you complete the study in the mid-age individuals. Um, have you what you see? What you
Yeah.
see like in that study? Have you ever examined like whether playing 3D video games brings the same beneficial effect the people who are naive gamers or not so techy individuals in their 40s, 50s, or even seniors, because as you know, most of the seniors are worrying about, they worry about becoming forgetful.
Mhm.
And there's memory boost are most needed in these age groups.
So after that initial study, one of our first questions was, could this be used in older individuals? So my lab, really one of the huge things that we try to do in the lab is we try to understand how memory changes with age. And one of the things that we have learned is that it's this hippocampus that is driving a good chunk of the age-related memory loss. So if playing video games can help younger adults, and if playing video games really is helping out the hippocampus here, it should really do something then for older adults who are starting to have problems with the functioning of their hippocampus and with this specific kind of memory. So our first follow-up study to that original one was to take this same study and do it now in older adults. So we were testing people in their 70s and 80s. And we said, okay, let's do the same study. We had a control condition. In this case, they were going to play a new solitaire game on their own computer setup. We also had the same Super Mario 3D World, and we had the same Angry Birds. Now, going into the study, we did give ourselves one possible little twist on the results that we'd had in the younger adults. We reasoned that for an older adult, playing Super Mario 3D World is going to be an enriching kind of experience for them. Solitaire on their own computer, probably not. They've played solitaire probably hundreds and hundreds of times, and there's at least not that much novelty. Maybe a new solitaire game to them, but it's not a lot. But what about that Angry Birds condition? Now, if you think about this, I have, say, somebody in their 70s or 80s, and we show up to their house with a big flat screen TV and a Wii U, and they've never gamed before. My generation is the first one that could have something like an Atari at home. They didn't. So this is a very novel experience for them. And so by that logic, we reasoned that quite possibly Angry Birds is going to have an effect in these older adults. Maybe it won't be as big as Super Mario 3D World. Maybe it'll peak out after a little bit, but let's be open to that, because really that's what the theory would predict. Sure enough, we actually ran this study for 4 weeks, a half-hour a day for 4 weeks. And what we found is that if you played solitaire on your own computer there, it didn't do anything. If you played Super Mario 3D World, it went up and up and up. And if you played Angry Birds, it went up for about the first 2 weeks and seemed to flatten off after that. So a little bit of enrichment by, oh my gosh, this is a new kind of thing. I've never played games before, gave some amount of boost. But something that really involved this spatial exploration and a lot of new levels, and a lot of that then seemed to have that continued effect. After that, we started to ask questions like, what really is it about the game? And so we turned to Minecraft. Minecraft is an excellent, excellent place for us to work because we can truly control the world. If you've seen, people playing it, they're out there, they're exploring and they're building things, and we could do just that, say go out in the world and explore and try to get back to the same spot each day. A lot of new places you're visiting, great. We could also take away the entire environment, make it absolutely barren, and give you a chest full of whatever materials you might want and just say, go do whatever you want. We could also then say, kind of take that same world, but now say, oh no, wait a minute, we want you to build this thing. Here's some instructions on how to build it. Start off with something easy and then move on to something more and more and more difficult until they're building these huge, these gigantic, very, very intricate kinds of structures, so that each time they're learning how to do something new. And what we found in that study was that if we just say, go do whatever you want, people often didn't do a whole heck of a lot and there wasn't any improvement. But if you were exploring the world on your own, if you were learning to build new structures with more and more complexity, or if you did both of them, yeah, you did better. Your memory improved. And that's the one also that we've now been able to replicate in middle-aged adults, showing that it doesn't really matter whether you are 20 or 40 or 80, we can see these kinds of effects.
Wow. So age seems like it doesn't matter
Doesn't
to
seem to matter.
improve memory. And I'm surprised the 70, 80 seniors can actually learn how to play 3D Mario World. But I know the game, it's not super difficult. It's fun. And you just jump and grab some gold coins and collect the coins and defeat the enemies and help your friends. I think that's such a fun game. And Minecraft, oh my God, it's so exciting. The seniors actually learn those games and play those games, and who are actively engaged in those games actually showed memory improvements in the study. So this whole thing mentioning, and does your research really suggest playing certain types of video games like Minecraft or the 3D Mario World might reverse age-related memory decline? I think that's huge. So is it a brain functionality change only, or accompanied with the structural brain changes, for example, the hippocampus size? You mentioned multiple times the hippocampus, that specific brain region has a role in memory, learning, and navigating space. As we age, that hippocampus shrinks and the size becomes smaller and smaller.
Yeah, so this is another thing that's one of the other absolute key questions. We have some hints that we can actually see at a microstructural level. We have some hints that we can see some measures that change with age. And then when you do one of these interventions, we can see that it starts looking a lot more like the young kind of pattern here. But this is something that we're actively trying to pursue in the lab and figure out what's the best timing to do on these kinds of scans, what are the best sorts of scans to pick up on it. But that's then the next great hurdle for us to be able to overcome, to really be able to say that, yeah, this is exactly how this is working for us.
Because this type of research actually showing there is a change in hippocampus size among older seniors, and compared to the younger folks, you need many participants. And
exactly. We need a lot of participants because there's a lot of variability from, in the hippocampus volume from person to person. There are even time of day effects on this kind of thing. This is something I've been studying. I'm the director of our MRI research facility here. And so this is something I've been studying for a long time. But we do need to have a lot of participants, which then is a lot of time and a lot of money. We do need to have a large enough sample size to be able to say that it really is the fact that we're having them do these games and not something else that's going on, to be able to really pick it out. I've got one finding sort of sitting on the computers in the lab that I've looked at. I'm like, wow, that looks pretty good, but I'm not putting it out there. I'm not trying to publish it until I can really replicate that myself.
Yeah, because as a scientist, we need evidence and enough evidence to prove.
As Carl Sagan said, extraordinary claims require extraordinary evidence. And so I want to make sure we've got that evidence before we put it out there.
Love it. So how about, have you ever tested people with medical conditions like MCI, the mild cognitive impairment, or Alzheimer's dementia? Do they show the same memory improvement?
So informally, we have some of our participants have been at that level of MCI. And right now we've got a large grant proposal under review from the National Science Foundation. And I had another one under review at the National Institute of Health to do just this. Because as we all, well, those of us, as you start to get more and more, in my case, white in my beard here, we know that, yes, this is memory that is changing with age, and that is a frustrating thing. We also, of course, know that this is what's critically getting hit in things like mild cognitive impairment and Alzheimer's disease. So we have a little bit of evidence on that right now, but that's something that I'm truly hoping to be following up with our Alzheimer's Disease Research Center here at UC Irvine in a study hopefully soon.
Best wishes for your research funding, and because that research, if funded, and once you start the research, that really brings benefit to the communities who suffers memory loss and Alzheimer's dementia. Thank you for doing that. So to me and many of us, during this pandemic, playing 3D video games is a perfect way to boost the memory as well as engage with other family members or the friends. But I'm sure we all agree as well too, like real world in-person experience is priceless. And your another research that real world experiment, so-called scavenger hunt experiment, also demonstrate that real world experiment is equally effective at boosting memories among older adults. Would you share more details about your real world scavenger hunt experiment?
Certainly. If we're right, and this is really coming down to having novel, rich experiences, video games should just be one way in which you could do this. So we reasoned that we could do something like that in the real world. So we had a group of older adults, and what we did in this experiment is we had them go to a park and find locations in the park that they never found before. So we actually wrote a little app for a smartphone that we provided for them, and it would say, go find this little thing. Maybe it's the corner of some sign. It's nothing of any consequence, but it's just go find this little thing. I have no idea where it is. Well, start walking. Phone says you're getting warmer, you're getting warmer. Oh, no, you're getting colder. Oh, there it is. Ta-dink. Great. Now go find this other thing, and this other thing, and this one, and this one, and this one. So we would have them go back to the park day after day, and each day they would get a collection of locations. They would repeat some of them from day to day, and they would go and learn where these are. And after a week, we had them do a different park, and then a different park, and a different park. So the whole idea was to get people out into the world, to get them exploring and doing something new, to be learning something new, in this case, just different locations of arbitrary things inside of these parks. And we found it had the same exact benefit as playing a video game. So all of this keeps pointing to not that video games are the one way in which you can do this. You can do a lot of things to be able to get this. Go for a hike in a new area, go explore, go for a drive into a new place. A lot of this is then that doing something new. Now, video games are a great way to do it because you don't have to be able to get out and do it. You can go and be transported to a completely different world, to a completely different time. You get all of this here on a video game console. You could go and travel the world and do it. You could go and learn, go to a new park, go take a hike in a new area. All these kinds of things can get you then that ability to have the novelty.
Absolutely. And video games, it's a great way to communicate, to engage with people you normally cannot engage. Because in the
Absolutely.
game world, right? Because grandchildren and grandson and grandfather, they can play together and
Yeah.
they play with and against each other. And maybe some people with physical disabilities or mental
Physical
disabilities.
disabilities, inability to get out of the home, a whole host of reasons why being able to sit there in front of a game, and maybe you have even a headset on or something like this, and then you can be talking to friends and be playing together cooperatively or competitively against each other. These kinds of things can give us connection. And it's a great way then of using technology to bridge that sort of divide. And it's fantastic if you can do it in person. Absolutely. We're still in the throes of a pandemic, which makes that difficult. And even without that, time and distance can easily get in the way, as can, as you mentioned, physical disabilities. And these can make those disappear.
I completely agree with you on that. And let me go back to the real world experiment, the scavenger hunt experiment. I think that's very fascinating as well too. And I think there is a message to the seniors and other kind of individuals in their 40s and 50s and whatever ages, when you go out for hiking or walking with your friends, do not just go walk around and back home. Do something else like you did at a scavenger hunt experiment. Set some goals like, okay, let's find out certain flowers
Mhm.
or certain birds nest, and set some goals. And while you are walk around and hike around, try to find out those objects and compete each other how many objects they find. And that's more kind of environmental enrichment
Exactly. It's leading to
things.
new things. If
Yeah.
you remember before, I'd said that Richard Morris says that the hippocampus is the automatic encoding of attended experience. So attending to something new. What is that bird? Where does this trail go? Oh, what is this tree over here, etc. You're giving yourself something new. And we can't say that for absolutely certain just yet in this, but all the signs are pointing to that's what's actually driving this effect.
Thank you. And I'm curious, and I'm sure our audience also curious about yourself. How you, what makes you, what motivates you to become a neurobiologist, and what training you take? What makes you interested in brain functions and memories and using video games as a research tool?
So for the benefit of younger folks in the audience, I'll start off by saying you can call me a washed up astrophysicist. When I went to college, that's what I wanted to be. I was fascinated by trying to figure out how can we figure out how the universe works? Where did it come from? Where is it going? How does all of this work? We have just a little tiny bit, little lens, sometimes literally, that we can look through to then go and try to figure this out. It turns out I don't think like an astrophysicist. I found that out fairly quickly in college, and I started searching around for other things, though, that really did sort of grab my interest. And that rapidly turned into experimental psychology and cognitive neuroscience. And I'd taken a course in college from a gentleman, Daniel Schachter, who's one of the absolute pioneers in learning and memory. And there was a phenomenon of amnesia that I thought was absolutely fascinating. If you've seen any documentary on memory, they always profile this patient HM. If you haven't, just think about Dory and Finding Nemo. So here is somebody that can't remember what happened 30 seconds or a minute ago. All sorts of other things, skills and everything, and their existing memory from a long time ago is perfectly fine, but some damage has happened in their brain and it led to this. And that struck me as, I wonder why that's the case. And so from there, then going on to get my PhD with Jay McClellan, doing neural network models of this. This then had sort of really grabbed me as to why the brain would have something like this and how does it work. But in truth, it's not all that far from astrophysics, because we have something, the brain. It's incredibly complex. We don't really know how it works. We're trying to figure it out. We can only look at it in certain ways and get little tiny slices of it. And we're trying to figure out how this incredibly complex kind of thing actually functions. It's a little bit more down to earth, I guess, for me. And so maybe that's why I ended up sticking to neuroscience.
Wow. And to me, like neuroscience is very similar to the astrophysics, because our brain networks and neuronal cells and sparkling um, electrical signals and exchange information is very much like the universe.
Mm-hmm.
So I don't know why, but your research are all fascinating, because in addition to your video game research, your other research on false memory is absolutely fascinating to me. So would you mind sharing what false memory is and your research on how our brain construct or retrieve memories and why we have false memory in our everyday memories.
Yeah. So one of the things to realize, I've said that the hippocampus is trying to go and stick away these experiences that you have. It's an incredible amount of stuff it's trying to hold on to. And the truth is, it just can't. It's not going to perfectly get everything. And so what happens when it doesn't? Well, when it doesn't, we fill in what we sort of expect it should have been based on our prior experiences. And researchers have known this for a long, long time. Frederick Bartlett had said, that memory is not the re-excitation of innumerable fixed lifeless ideas and fragmentary traces. It's not bringing back all of this stuff that's been fixed and sort of etched into your brain. Instead, it's an imaginative reconstruction or construction. And he said it was basically built out of this huge organized mass of everything that's happened to you before and to a little bit of outstanding detail. It's that little bit of outstanding detail that's what the hippocampus has really gotten for us. And everything else is being filled in. So in truth, actually, when you're remembering what you did yesterday or the day before or anything like this, a lot of what you're doing is not actually from that one event, but you're actually filling this information in. And a lot of the times it works great, and we call it a true memory or an accurate memory. Other times it doesn't work so great, and you have mistakes on it. And we call that a false memory. Now, it's not a lie. You think that it's true, but it just isn't. It's just wrong. Now, if we think about why we have this memory in the first place, it can kind of give us a little bit of a handle as to why we have memories. We don't have this memory, the ability to remember what happened yesterday or where some food was or where we found water in the past or where a particular threat was or something like this. We don't have that so that 30, 40, 50 years down the road, we could sit back and say, geez, I remember when, and somehow mentally time travel and relive that experience as if it were yesterday. That's not why we have memory. In fact, memory really isn't about looking backwards. Memory is about looking forwards.
Huh.
The point of memory is to get it so that you can make better, more adaptive decisions right now. That's why we have memory. It's so that our past, we did something that's kind of related to this, and maybe we should let that experience go and tell us to maybe not go into like a deep, dark cave just by ourselves. Maybe there's a predator in there. All right. Or maybe that berry was something that made us sick, or that's a spot where I actually found some good food. This is why we have our memory, so that those past experiences can guide us and have us be more adaptive here and now. And if you think about memory that way, the notion that you're going to take a whole bunch of really kind of similar events and maybe munch them together into one thing that probably kind of should have happened, that makes sense. Sometimes we call that wisdom or knowledge, and we extrapolate across these. So in fact, in our brain, we have some systems that are trying to hold on to every last little bit that happens, and they kind of work some of the time. We have other bits that are really trying to put all of this together and try to come up with some general way in which things work. And these are always interacting with each other and each giving their own answer and pushing it on, combining it all together. And that's what drives our behavior. So the fact that we have false memories is completely to be expected. Every time you're remembering something, you're doing some amount of filling in based on a whole bunch of stuff. And if that whole bunch of stuff is all consistent, you fill it in correctly and it's great. And if it's not, sometimes you're wrong. Okay. But we've all had that feeling where it's like, oh yeah, that's right, because this and this and this. And you tell a story and somebody says, oh, wait a minute, hear that? You'd already moved when that happened. Oh, you're right. No, it was this and this and this. Oh, okay. Well, that first one was clearly a false memory. You thought it was true, but all memory is being reconstructed this way.
Wow. So I'm fascinated that our brain is imperfect. And it's not just functioning like the videotape recorders and record exactly the same thing and replayed it later. When we retrieve memories, it seems likely we add our own bias and previous experience and expectations in addition to the actual event. But based on your research and what you said, that false memory, some portion of our memory is false, and false memories are not wrong, and it's just a normal part of everyday memory.
Exactly. It's look, we also, when we, if you go and you hop on the web right now and search for visual illusions, you'll see some things that just absolutely are mind-boggling, and you're, oh my gosh, that, whoa. And well, false memories, there are memory illusions as well, and both of these point to really how the underlying system is actually working. It's not perfect. It works pretty darn well, and that's how we can get through life and do this. But even people who have incredibly good memories still have lots of gaps in them, still have distortions in their memory, still have some things that are inaccurate and this kind of thing. All of those folks, in fact, we studied a number of them in the lab, all of those folks will still have some things that, certainly things that are missing, and absolutely some things that get distorted as well. It's just fundamentally how the system actually operates. But that's okay, because if you really had the ability to relive every day, minute by minute,
That's a disaster.
why would you do that?
Yeah.
And for one thing, it also would probably get it so that finding information would be that it's all this clutter of useless bits. In fact, there's a story, Funes the Memorious, about somebody then who did this. It's fiction, but somebody who then found that, of course, reliving a day took an entire day, and so it actually ends up being a problem. There are multiple ways in which we can actually see that having too good of a memory is a problem. In post-traumatic stress disorder, what you find, of course, is that there are very, very strong, horrible memories that some cue will trigger, and they will relive this horrible event, and that's a problem in their lives. It's too good of a memory. In fact, actually, you'll often see in those memories, the contents of the memory get distorted and actually get more and more horrific over time. So even those tend to change. When you think about something like drug abuse, well, you've actually had some initial events that were incredibly reinforced by these drugs, giving you this massive hit of dopamine, saying, learn this, this is really important. And now you can't break out of that habit. Habits are learning and memory. Obsessive compulsive disorder, again, has this sort of notion of these habits that you can't seem to break out of because that memory is too strong. There are many, many aspects, of course, to each of these kinds of conditions here, but memory being too strong is one of them. So in fact, the notion that we have a memory system that does forget things, that munges things together and calls it knowledge and wisdom, maybe that really is the most adaptive way of having it. Having something that would be perfect would be a problem.
Yeah, I agree with you. And perfect memory is not the the perfect thing, not a good
Exactly.
thing. Forgetfulness is actually the blessing,
Mhm.
and false memories is a blessing as well too. So relate to that. So do you think, can we scientifically manipulate memories just like the movie Totally Core? In other
Absolutely.
words, is it actually possible to implant force memories? I mean, not force, meaning like more desired memories for individuals you mentioned, like suffering from PTSD. And is there any way we can retrieve the lost memories from people with Alzheimer's dementia? Is it possible?
Yeah. So we'll pick a couple of those off in turn. First, we have known for a long, long time that, yes, you can implant memories. The pioneering work here done by Elizabeth Loftus, she's one of my colleagues at UC Irvine here, it showed how she had an early study, the Lost in the Mall study, where she could show she could implant a memory of a traumatic event like being lost in a mall. This has been taken further and further and further over the years, and time after time after time, it shows that, yeah, you can implant false memories. You can do things like, as soldiers are in prisoner of war training camp and they're being interrogated, after the fact, you can very, very easily actually in the person's mind change the contents of the memory to have it be somebody else who was interrogating them, or they were wearing different clothes, etc. These kinds of things we can see just with simple behavioral measures, behavioral techniques, you can go and change. Um, in addition, if you start then saying, what can we do biologically and neurobiologically, there are a lot of things that we can do. So researchers have shown how you can implant memories of events that never, ever, ever happened just by basically stimulating the right kind of pattern on neurons in different ways and having a little bit of some pharmacological help inside the hippocampus there. But you can also do things like erase memories. We've known for a while there's a phenomenon called reconsolidation, in which when you activate some memory, it puts it into a particularly malleable state, with the idea being that, oh, I'm thinking about this, I have some new information, let me go and change the memory and then lock it back in. Remember I said before that we take lots of memories and kind of stick them all together? Okay, here's a nice neurobiological mechanism of it. But one of the other things that you can do is, while it's in that state, there are a couple things that we can do. Use anisomycin, ECT. There are a number of things that you can do to block the required protein synthesis that sort of locks it back in. And if you do this, at least in experimental animals, we've seen that you can eliminate the memories. So there are things we can do to make memories get very, very strong. Marcella Wood here at UCI has been trying to use this to actually help in drug addiction. So in a rodent model of drug addiction, being able to get it so that the animals learn that, hey, wait a minute, maybe this drug isn't such a great thing to be able to go and actually seek out so well. If you crank the learning and memory up on that very, very strongly, it can then go and start to show that, yeah, it may be able to actually do this to help break out of that addictive cycle. Now, a lot of these things always then have to make the leap from studies in animals to studies in humans. But these techniques are out there and these kinds of things can be done. Now, when it comes to something like Alzheimer's disease, people who know people who are suffering from Alzheimer's know that there are some good days and there are some bad days. So there certainly is some amount of information that is still there that, on other days the person just can't get a hold of. That said, as the disease is progressing, more and more and more information is truly being lost. Took a look at the brain of an Alzheimer's patient, you see just the incredible shrinking of the brain and the real loss of the neurons that are storing all of this information here. So can we do some things to slow that down? Can we do some things to try to be able to get at some of those memories that are still there before they're gone? Yes, this is the kind of thing, obviously, that is actively being done in labs across the world. Once you've gotten to some point here, it's going to be exceptionally difficult, if not impossible at that point. So that's why so much research is on prevention, on early detection, on being able to slow any sort of decline, being able to intervene at that, oh, you're starting to have some issues. Let's try if we can do anything right now to slow that, to maybe delay it by 5 years. Wow, think about how much we could do to really keep a lot of quality in people's lives.
Absolutely. And it's so wonderful to hear that there are many scientists in the world actively researching this area, the forced memory, or kind of implanting memories to help people with certain medical conditions. I think that's absolutely amazing, but it seems likely at this stage, it's more like the animal research, not directly applicable to human being yet, even though the science
So,
evidence is there. Is it due to the ethical issues?
well, yeah, so it depends on what really the manipulation is. But even if you take something like a simple behavioral thing, I convince you that you were lost in the mall or that you'd gone to the hospital, or, well, I'm telling you something that didn't happen here. And this can have big effects, or even just the realization that you're so easily manipulated may have big effects. But if we go back several decades, there was a huge scandal as all sorts of people were having recovered memories of really, really horrible things that purportedly happened in their childhood. And there are absolutely horrible things that do happen to people in their childhood. There are certainly people who choose to not think about those kinds of things, and only later, as they can cope with it, do think about them. But we also know that if you have somebody, for example, a therapist who's having you try to imagine and do a lot of reconstruction and try to imagine what it would have been like, et cetera, that those are the same techniques that can be used to implant a memory. And so the ethics of this, when we're trying to do it in the lab here, do get complex very quickly on a number of these issues. And certainly when it comes to any sort of invasive procedure on the brain. That said, people are now trying to see, can we use this in drug addiction? Can we use any of these techniques in post-traumatic stress disorder, in a whole host of different domains, to try to say, okay, let's take what we can learn, just like as we're trying to use environmental enrichment to help out our memories. How can we take those concepts and those ideas and those mechanisms and be able to, actually do it ethically and reasonably in people? Because people do need help.
Absolutely. Thank you so much. So this is my last question. So what research is happening in your lab? Do you have any ongoing or prospective studies that you actively look for participants? And what is the best way we can get this information?
Absolutely. So we'll give you the link to our lab website. And at the top of there's a thing, hey, do you want to participate? So going on in the lab right now, one of the huge things that we're trying to figure out is, how can we determine whether somebody is having a typical kind of age-related memory problem, or whether this is actually something that may be a real problem. And to do this, we've got a memory task that we've been working on for a good number of years, and we have a nice grant to be able to then go and turn this into something that maybe you could just do at home yourself. Or if you're over 65 and you're in the doctor's office, you're at your primary care, physician's office, and part of Medicare Plan B here is then to be able to get some kind of good assessment. So we've got a tool, and we need help in really helping to test out that tool and really, really validate it in as large a sample size as possible. And so this is the kind of thing where we need thousands of people to be able to actually go and take this. And sometimes it's just a one-off half-hour kind of thing, doing some tests from the comfort of your own home. Sometimes it may be taking the test, once a week for a few weeks or something like this, so we can get a good handle on exactly how this works. Because at the end, if this can be used as part of the way in which we can really determine, yeah, your memory may not be what it was 20 years ago, but so far it's seeming to be just fine. It's pretty typical. Versus, maybe we should follow up with you. If we could have a simple behavioral test that would do that, that would be an incredible thing actually for society. So we're working very actively on that project right now, and pretty soon, hopefully, we're also going to be getting some more things going on with video games. But if people want to actually help us out with that, we would love it.
Oh my God. Thank you for sharing that information, because I think this research you are currently running at your lab is important, because many seniors, and as we age, we forget things. And we always confuse and worry about, okay, I keep forgetting things. Is this the normal aging process, or am I getting into something serious? Do I need to think about some medications or seek medical help? It's always difficult to find that fine line where I am, right? Because am I in the normal aging that line, or am I in that serious memory problems? So your research participation and result at the end help us to develop a tool to help us kind of easily find out, okay, you need to seek medical help, or, oh, it's okay, you are in the normal aging process. I think this is amazing research participation opportunity. I'm sure to share this information with our audience.
Thank you. And this is why we need, so we take, in this case, it's 18 on up, and all backgrounds. The idea is we need to know what people of all ages, of all backgrounds, of all everything, what really is normal. And so we need a lot of people to really be able to determine that.
Thank you. I'm sure to post that information and share it with our audience. Oh my God. Thank you so much. Thank you, Dr. Stark, sharing your research and sharing your insight. This is amazing. Thank you.
Thank you.
So, audience, our brain is plastic. It changes with our experiences and what we do and what we see and what we experience in life. Basically, what we put it in, that become our memory. And a growing body of scientific evidence shows that the playing video games affects our brain positively as well as negatively. As we learned from today's talk with Dr. Stark, playing certain types of 3D video games is good for our brain health because it can boost memory functions. And more surprisingly enough, video games is not just an entertainment tool and you just kill your time. It can be used as a medical research tool in this important brain research. There is a proverbial phrase, when life gives you lemons, make lemonade. If you cannot avoid your children or your significant others playing video games, how about turning that into something good, something fun, and something beneficial for your children, yourself, and your whole family? Grab your laptops, computers, or Switch, learn how to play certain video games that Dr. Stug mentioned and he tested in his research, like 3D Mario games or the Minecraft, and instead of family game time, and use it as a family bonding opportunity as well as a way to stay cognitively healthy. If you are interested in learning more about Dr. Stark's research or potential research participation opportunities, follow Dr. Shin Science Cafe at X Media. Thank you for joining us today. Stay tuned. I'll be back. Thank you, Craig.
Absolutely.
Oh my God, but your current research is exciting. So isn't that so send me the link or send me the flyer, whatever the information you want to share.
Will do.
We will definitely sharing it with the audience, and whenever the opportunities, other opportunities come, like the PBS one or anything, I will let you know.
Cool. Yeah, no, as I say, this is the, it's easy for me to get 20-year-olds. It's not too bad for me to get 70-year-olds or something like that. The in between, that's not easy. And